Okay, so now the question is whether if this is just because across the parameter W2, there's not much that we can do. Or let me try two things. On one side, I will try to change the learning rate to something bigger. This is just given by train learning rate. We should eventually just merge these things, these two files, I guess. 0.1 should just be okay, I think. Let's just try it like that. Let's just do 3 epochs, because then just like 5, it takes too long to test. And let's just run these once more. Python train.py. And so the point here being, it's either these, or maybe then what I could also just try to do is let's just basically put all the parameters, right? You know what I mean? Why is it that sometimes it works like that? Oh, I guess it's fine. I don't know why. I guess when I was printing the other shit, I just don't know. Is it just that I don't know how printing works? If I print, for some reason if I was printing like the DW2 or something, it was just all the time. Yeah, of course, it was just kind of printing everything in here in between. But anyway, so epoch 3, let's see. And if that doesn't work, then my assumption is going to be that we can maybe just try and parameterize already by B1. Essentially, we need to parameterize by B1, W1, and B2, I would say. These are the things that we need to parameterize. 4, I guess. Yeah, I mean, that's all flat, right? It's just not changing anything, which is very confusing. Now, W2. Well, I mean, I'm changing W2. I'm calculating the grad every time. So maybe that's something that I shouldn't be doing like that. Backward. And maybe I'm calling this wrong. So what am I doing? I'm going here, I'm doing a forward pass, and then I'm just asking it to calculate to do the back propagation. Now, back propagation, what back propagation will do is we'll calculate the grad of this function. But the thing is, I don't have to calculate the grad of this function every time, right? Well, it will just do it once. It will just do it once, I guess. It will just do it once. Is this the right thing? That it's happening every time. I call backward propagation. I'm doing that. Or can I just do it once? I'm trying to think if this makes sense at all. It's always going to be with respect to whatever x I'm giving it, right? Because essentially x needs to be part of the stuff that I'm... No, that is fine, because I need x and y true is going to be different every time that we do back prop. I guess that's already okay, because what we're doing is we're modifying W2 with these, right? I guess that's fine. Is that fine? What if I wanna? What if I wanna add multiple parameters to these? It should make a difference, right? It should. It really should make a difference. I just don't get why. This must make a difference. I can't believe that it just makes it definitely shouldn't make just zero difference, right? It's just not possible. It means W2 wouldn't have any influence on that. So I'm doing something wrong 100%. I'm 100% doing something wrong. We're in the training loop. We've got a specific X, and then we run this back like the forward function. We get an output, and then we take a look at this output, and then we're trying to change these this thing with x1. X1 is actually the reshaped version of X, so that's all good. So we're putting these in here, awful naming, blah 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 blah, and then we calculate these. That's not used anyhow. I mean, wait a second. These are one. It's used here, so it's calculating these. But I'm not doing anything else with this information. DA1 is used in here, DSI1 is used in here, this is not used, this is not used, that's all fine. So I'm just basically trying to do these, right? So but that just seems to be too small. Then I'm just basically calculating it like this, right? Grad W2 and passing it the W2 value. Maybe that's the wrong thing to do. Maybe I'm just getting it wrong. So autograph. So how to use grad in autograd properly in the context? It's simple neural network. To the parameters of the network. Okay, so using now PyTorch, whatever, but it doesn't. So essentially, compute grants manually grads. So he's using all the parameters, and then init forward, simple NN. For each parameter, yeah. Loss calculation, criterion, predicted target. Compute the loss. The grad is essentially interesting, right? What are these other parameters? Name parameters, create a graph. Maybe I'm just using it wrong. I want to know from AutoGrad. From GitHub, AutoGrad. Like the actual these one. That's what I'm using. Docs. Update guide tutorial. How is AutoGrad? So simple neural net. No, maybe there's another example. There's another example. I think there was a backpropagation through a fluid simulation. That's fine. A simple neural net. It's kind of doing the same, right? So print objective. So you have objective and it has the parameters and either patch indices. And then there's log posterior of this shit. And then grad objective. Objective grad. Because then it's putting it, in this case, it's putting it through an atom optimizer. That's fine. Step init parameters. That's what's doing the job. What I'm trying to do is, I think I'm just missing. I think I'm just missing the point. I'm just missing that tells me the gradient, but it doesn't tell me. It doesn't actually tell me. It doesn't really tell me how to optimize it, right? Because that's what the atom optimizer would do. It would give me the optimized parameters. All right. Train accuracy. It actually, I'm doing this wrong. I see that. I'm doing this the wrong way. I need to implement some sort of optimizer. I'm doing this wrong because what I'm getting is I'm getting the function, but I'm not getting where the gradient kind of goes. Before, I'm trying to think what is the difference between what I was doing before here, like manually calculating that derivative, right? You know what I mean? Like the point is, I'm just trying to think about, like, again, what I'm doing, right? So the derivative is another function. So let's just imagine in terms of in terms of a function, and then that derivative is like these. So if the derivative of a function, let's say 2x or x squared is basically 2x, and I find myself on one side or the other, I replace it, and that actually tells me, now that, I mean, that should tell me where I should go, right? You know what I mean? Like if I have, if I just have like a, can I just, I'm missing some sort of quick, like quick new file, whatever. I just don't want to give it a name. I'm missing something to just like pop up some notes, you know what I mean? But maybe something like, oh, give me a second, guys. That might be something a little lower. Yeah, so, where was I? It has to work. This has to work, right? What I was trying to say, what I was trying to say is that if I open new one and say like test dot, I think that works now. Huh? What the fuck? No. Files. No. New file. New file. So if I have like a function that is like these, right? X squared. I don't have a mouse, and so that's shit. Doesn't matter, but essentially the derivative is 2x, right? This means, fuck shit, that if then x, if this is x and I am on the positive side, I'll get number here. So I know that I have to go down. I have to kind of minus the result. If I am here, I know I have to be if it's going to be minus, I know that I have to be like plus. I have to increase the value of x versus I have to decrease the value of x to get to the minimal. So that should already tell me what I'm trying to say is these here. Maybe I have to fucking minus it now then. Maybe now it'll work. How can I? Okay. I mean, I will work. You know what I mean? Hopefully it'll not explode now. But I think that's the whole thing, right? So I think that should be more than enough. But if it doesn't move, then I just don't get it, because in this case, to me, this is like a pure black box. Then again, it's just a definition problem. I'm taking the gradient of this function. Maybe I should just print what this gradient is. Can I don't know if I could plot these somehow. Probably I cannot, because I don't know. You know, I'm giving it the input that it needs, that the function needs. This is going to use it as, boom, objective W to thing. That's what I'm deriving. That's what I'm doing the gradient of. And that should just tell me, that should just kind of like it just can't be, you know what I mean? It can't be that it doesn't move the needle. It's gotta. I'll keep trying, you know. I'll keep trying. It doesn't work. Keep trying. Where's the output? No. It can't be. It just can't be. It cannot be possible. Something's wrong with the way that I'm doing these. Something's wrong here. Crud. How can I plot these? Like self W2, right? The thing is, forward. It started with something kind of random. Yeah. It's stored in there. The forward passes use it. Now I want to modify it. But it's not really telling me. It's not really telling me why or what's wrong here. Maybe it's got to do with the way this is defined again. Like maybe this thing with lambda is definitely not, maybe this is not a right technique. Technique. Why do I even need? Maybe what I should do is, can I just define that as an inline function? Whatever. Can I just use that? No, but that's a lot of parameters. That's a lot of you know, you see, that is the thing, right? That is the thing. That is the damn fucking thing. Maybe the whole problem here is the way this is structured, right? So, because it's making a lot of references to self, which, like, right? So can like this grad, let's see if AI can help me here again. Does grad work well with functions that make reference to self and object level variables? You know, that's the standard mathematical function. That's kind of what I'm afraid. Key points. How you call grad? You would likely pass the internal state or attributes of the object explicit arguments to make it compatible. But the thing is, I just want to make, what I want to do is, what if I just want to optimize across one parameter? What if I just want to, okay, so get function for grad. Self A. Okay, let's, does this work actually? Let's try this. I mean, why not? 12. The gradient is 12. The derivative is 2x. 2x, a is 3. 3 times 2 is 6. 6 times 2 is 12. So that actually works. With this being a variable. I mean, that works, man. What can I do? That works. Model get function for grad. Maybe let's do it this way. Maybe the get function for grad. Maybe that's the way. So objective 2 is just self and the parameter. That's TEF. Okay, so. And then let that. So how is this working here though? My function is self x. Okay, my function is x. Returns a lambda function that has this thing. So now basically, essentially, but I think that's the same, right? Self get function for grad. So essentially that returns a lambda function that's calling w2 with this parameter. Exactly. That's just the same. I think that's literally the same. And then grad w2, and then we give it this parameter. I think that doesn't change anything. I think that doesn't change at all anything. it worked. I mean, this code actually worked, and the 12 is really what we expected from a gradient perspective. So that should really work, man. Should really work. Even with references to like self Z and self A1, self XT, self W stuff and everything. Yeah. Self Y true. And then because essentially we want to optimize by W2, right? For some reason feels a little slower, but that works well. That works well. Should be fine. I don't know. That's today's video is like me saying this should be fine. Then it's not. Come on. Come on. It's fucking flat, man.